Hello, everyone. This recording is for Thursday, March 26th, 2020, and our title for today is Linear Relationships Review Continued. So we have I sent a recording for yesterday starting Linear Relationships Review, and so we're going to talk one more day about those relationships. Today we're going to again be reviewing slope and y-intercept so that we can write an equation in slope-intercept form, and we'll know if we got it if we can successfully interpret a real-world situation and write an equation to represent it. And we are going to be on page 12 of your 8th grade Math Star Review packet. So make sure you have that packet with you. You've got your reference chart with you, and you have your calculator. Remember, guys, at any time during this recording, just press pause whenever you need to, and then move forward whenever you're ready. You can go through this recording at your own pace. All right, so in that STAR review packet, let's take a look here. The first one says, write the equation of the line that has a slope of 5 and passes through the point 2, 2. The next question says, write the equation of the line from the graph below. So press pause and write those equations for me. All right, so for this number one, guys, it was kind of hard, but you have graph paper. So what I did is I put the 2 points on the graph that I knew. I knew point 2, 2 is right here. And then if my slope is 5, I can go up 5 over 1 and put another point there. Then I can just connect or draw my line. It doesn't show on this graph, but that shows the y-intercept being -5, which is our b. So y is equal to mx plus b. M is our slope, and it tells us that slope of 5. So we had to find the y-intercept here. That equation is y is equal to 5x minus 8. All right, I think it's a little bit easier to write an equation from a graph. So this one, we have to find our y-intercept, which is 2. It crosses that y-axis at 2, so my b is 2. Then I find my rise and my run. I use 2 points that are crossing that graph. They're in the corner of the grid so that I can count my rise and my run. So my rise is 3, my run is 4, so my slope is 3/4, or my m is 3/4, making my equation y is equal to 3/4 x plus 2. We have our interim questions. So this one was pretty short as far as the STAR packet. But let's take a look at the interim questions over the rest of the linear relationships questions. So number 11 from the interim said, a coach is ordering shirts for a team. The coach pays a one-time fee of $24. The coach also pays $8 for each shirt ordered. Which function can be used to find C, the total amount a coach pays in dollars when K shirts are ordered? So press pause and pick out the equation that matches this situation. All right, and so that would be B. C is equal to 8K plus 24. So the one-time fee makes this situation a non-proportional relationship. This graph would start at 24. The coach is going to pay that $24 before any shirts are even ordered. So for 0 shirts, we're at $24. Then we're going up by $8 per shirt. So our slope is 8, and our y-intercept here would be 24. So C is equal to 8K plus 24. All right, question number 26 from the interim said the graph shows the relationship between the number of gallons of fuel remaining in the tank of a semi-truck and the number of miles traveled by the semi-truck. So which function can be used to find y, the number of gallons of fuel remaining in the tank of the semi-truck after it has traveled X miles? So press pause and pick out the answer. And the answer here is D. Okay, so we have a negative slope, right? We know the line is going down. The fuel is being used, so that's why it has a negative slope. So we know A and C are out. B and D are the only two answer choices that have a negative slope. They both have the correct y-intercept. Where both B and D are starting at 240 miles miles of fuel remaining. But then we have to figure out how much the fuel is decreasing by. So if you'll take a look here, and I looked at 300 miles traveled, we had gone from 240 to 210. So if we did, that's a change of 30 and a change of 300 miles. So our change in X would be 300 miles. Our change in Y would be 30. So our change in Y over our change of X. Am I doing that right? Okay, and so 3 over 30 can be simplified to 1 over 10. So that rate of change would be 1/10. There we go. All right, I have a couple of star review questions for you now. Which equation is best represented by this graph? So pick out the correct graph for this, the correct equation for this graph. Press pause and press play when you're ready to resume and check your answer. The answer here is D. I always start by looking at my y-intercept, and that's not the correct answer. Oh, I was wrong. The correct answer there is not D. The correct answer, y-intercept, is -2. So A and D are out for that reason. Okay, so B and C have the correct y-intercept. Now I have to find my slope. And so I'm going to use these 2 points. And so my slope is up 2 over 8. So 2 over 8. My rise over my run is 2 over 8. So that would be 1/4. So B is the correct answer. Not D. All right. The last star review question, I believe. Maybe not. Maybe we have one more. We'll see. The amount Ben earns Y varies directly with the number of hours he works X, as shown in the graph. Write a direct variation equation, identify the constant of variation, and interpret its meaning. All right, the answer here is C. So the direct variation equation is 5.5x. So it starts at the origin. We do not have a y-intercept. For 1 hour, Ben earns $5.50. So $5.50 per hour creates a proportional relationship and gives us that equation of y is equal to 5.5x. We could figure out how much Ben would make for any number of hours using that equation. All right, guys, great job wrapping up our linear relationships review today. Today we looked at how to use data from a table or graph to determine the rate of change or slope and y-intercept in a mathematical and real-world problem. We also looked at how to interpret the unit rate as the slope of the line that models the relationships on a graph. So here is a list of your assignments for this week, guys. Once again, if you are struggling with anything at all, any questions whatsoever, please send me an email and I will be happy to help you out. I can respond to your email and work with you through email, or I can set up a time that we can meet to work together to work on any of these questions that you have. I hope you're having a great week, and I hope to see you soon.